restoration of the and the improvement of the foam properties. And this is where I will open a bit of a new chapter here. I still think, yeah, I'm late 1 hour, but Julian, tell me if I need to accelerate. Otherwise, we keep going. It's about this aesthetic of effervescence we've been talking about. All these products we've been designing has to be added at this stage at the tirage. That's where it performs best. What's happening, guys, is that basically there is many variable numbers of vinification stages, which might impact significantly and badly your foam properties. So one of them is the maturity. The maturity means basically that you will have a lot more glycoprotein and heat unstable protein that you will need to treat. Pressing, if you haven't pressed properly within this very specific program, champagne, the harvesting, the fining, the filtration might also cause retention of some of these colloids, which are beneficial for the foam properties. Of course, in case of botrytis, you totally ruin the foam properties. Then alcohol, that's also something that people are not really familiar with in general. But the higher is the alcohol and the worse are the foam properties. Because you need to know that alcohol is also an attentional active molecules, which is going to take place to some other attentional active molecules we're going to talk about, you'll see. And of course, we have this protein stability we've talked about already. So anyways, what means all this is that it's rarely possible to potentialize all the parameters during the process of winemaking for the foam, for these nice colorets, tiny bubbles, and all this. So that's where we have opened this chapter in 2014 with LAFFORT, a research program dedicated to the aesthetic of the bubbles. Having in mind that the grail for the tasters in terms of wine bubble and effervescence aesthetic is to observe these fine, elegant, persistent bubbles, which regularly feed this thick and stable colorette here, forming this, what we call harmonious foam. That's the old poesy of this job, of this sparkling wine making is there. So we'd rather not screw it up. Let's go back to a few fundamentals to understand more about these bubbles. Basically, for a flute like this one you see here, there is a theoretically 10 million bubbles, that could escape if you calculate that from the concentration of CO2 produced during the secondary fermentation. However, when you open the bubble and when you serve, 80% of the CO2 is disappearing like an evaporation, and these are phenomena totally invisible. You won't see them. But anyways, we still have a 20% of this CO2, which will be able to form bubbles. That means that in one flute of sparkling like this, we're gonna have 1 to 2 million bubbles. So that's quite a big phenomenon. And I like this picture a lot because you see the bubble burst and the aerosol which it creates around when it bursts. And all these bubble bursting are exploding quite high, and it goes directly to the nose. So, and it releases a huge amount of aromatic molecules, which are physically going to the taster. So when we're talking about a certain finesse in the style, this is exactly here. You understand that just physically with the effervescence, you have 30 to 40% more aromatic perception. So when you have something a bit aromatic, it becomes extremely aromatic, you see? And that's where it's harder ways to catch the proper finesse when we are dealing with base wine. So that's totally different mindset, I would say, as dealing with still wine, in which we really try to push the aromatics. So that's quite that was just in between brackets here, but let's keep going. Anyways, These bubbles, which is nice, is inside the glass from the birth to the time they raise to the surface. It's an interface gas liquid, and this interface is a perfect trap for these surface active molecules. Okay, because these molecules have an hydrophobic tail, which try to be in the gas form, as soon as possible, but the head likes to be is a hydrophilic, so likes to be in a water-based solution. Okay, so that means that when the bubble, this interface, which really cross all the length of the glass, will be a trap for these molecules. And these molecules are interesting because are also very aromatic molecules. And what is happening when these molecules these bubbles rise the surface is these surface active molecules will also be the one that resist the bursting. You see, first of all, they make the bubble resisting the growth, because the CO2 dissolved will not be able to go inside anymore the bubbles thanks to these molecules. And when they reach the surface, it will also delay the burst of the bubble. So for you to understand good, I took the example here of the sparkling water. In the sparkling water, what's happening, there is absolutely no surface active molecules. So when the bubble reaches the surface of the glass, instantly it explodes. All right. Whereas in the beer, it's the opposite. There is too many of those, and too many of those makes the CO2 still diffusing, and the bubble is growing, and indefinitely. And this means that aesthetically, it's not super appealing. If you would have a sparkling wine with bubbles like beer, wouldn't be appealing for none of us. So the point is to find the right amount and the right molecular weight of these surface active molecules to have something enough for resisting, but not too much to not resist too long. Okay. So basically, we have been experimenting because, guys, we are working on nanoproteins since '96, if I recall, from Virginie. And with many patents, and we have also set a factory to produce these different nanoprotein fractions. And we wanted to screen this nanoprotein fraction and to see how aesthetically they react in the sparkling wine. So we've been adding some of these nanoproteins, as you can see here. You see EL as well, and the témoin means control, into Crémant from Bordeaux that has been treated with 800 ppm of bentonite, okay, on purpose. And then we looked, thanks to the University of Reims and the Laboratory of Physics of the Bubble, one of its kind. We looked at the different parameters of CO2, etc., to understand when I serve which of these nanoproteins have the best impact on the visual aesthetic of my sparkling glass. Okay, so let's directly look in order to really be able to compare things. You need to have bottles with the exact same concentration of CO2, and the concentration of CO2 from the time you serve to 600 seconds after, so 10 minutes after, needs to be within the same range. If it's outside this range, as you can see, this red curve, the EL is outside the range of CO2 lost. So that means I cannot compare the EL to the other modality because the CO2 is too far away. The CO2 concentration is too far away from the others. Okay. Anyways, let's have a look at pictures because I think this is what really speaks best. You have a control here. And this is the picture in standardized conditions in the lab, right? In the flute, in the service condition. And this picture shows you at 1 minute for a wine that's been aged on lees 12 months, okay? And this column is 1 minute after service, and the right column here is 10 minutes after service. So you see that the control has not a lot of bubbles in the correct 1 minute after to start with, And 10 minutes after, let's be honest, there is everything has almost disappeared. And what we found quite funny, you see, as soon as you put some monoprotein in the wine, straight away you see that the colorate, the thickness comes. So the monoproteins are perfect tensioactive molecule for the sparklings, but the size of it really impacts the outlook of the bubbles, you see, and the aesthetic of it. So for example, the MP1, if you agree with me, it's more looking like a Guinness than a nice, elegant sparkling. What we look at, basically, so these are the parameters, the diameters of the bubble in the colorate, is something ideally which is around 0.4, 0.5 milliliters as a diameter of a bubble. So these are these bubbles. So in the control, the bubble size is good. The problem is not the size of the bubble. The problem is the amount of the bubble here. But you see that certain monoproteins improve the resistance, but in terms of size, it's not ideal. And some others are even a bit bigger, you see. So our work and since 2014, we've been screening different monoproteins and then to see how we blend them, what is the impact, to find which one would have the best compromise in between resistance to bursting and size of the bubble on young wines. So let's have a look now. What does the on-lees aging on foam properties? We know that there are also monoproteins in the yeast. If you leave your wine on the yeast aging for a longer period, and as you can imagine, here after 24 months, well, naturally, you rebuild your foam property. So that was something we would expect. This shows it to you. So that's after 1 minute. But then after 10 minutes service, we also see that this quantity of monoprotein is not the perfect one, you see. The bubble starts to be a bit big. So our aim was to design something which stays a bit consistent within the time as well. So first of all, after 12 months aging, you have a perfect service. And afterwards, we try to keep on the same bubble size. So all of this has been triplicated. So you have the diameter of the bubbles at 24 months, okay? So we have here the control at 24 months. So you see the control, the average diameter of the bubble is in between 0.6 and 0.8, when the monospark that we look at is reaching almost the 0.4, which is where we want to be at. And funny enough, 12 months, the MP1 was not good, but it's almost okay at 24 months. So you understand all these things we've done. And in fact, what happened with Professor Gérard Ligier-Belair, I know probably some of you has already seen him in the US. I know he's done a few conferences in the past. Well, that's the first time we're publishing that the contribution of the yeast monoprotein added at tirage on the foam property, so on the size of the colorate and on the persistence of the on the size of the bubble, sorry, and on the persistence of the colorate. I'm starting to get tired. I should accelerate a bit, but we are reaching almost the end. So anyway, for a little reminder, the supplements we propose are restoration and improvement of the foam property with monospark in case it's mistreated, acceleration of the on-lees aging, anolees, and you could also go ahead with a preservation of aromatics thanks to inactivated yeast and rich in glutathione. So here we are more in the area of Charmat method, which is really a product I recommend for the Charmat. A very last thing, guys, before leaving you, is a new innovation we are launching this year. It's called NobiSpark, and this is a new idea. Basically, I will go all the way to the end. The concept of NobiSpark is to do a secondary fermentation in the bottle with oak. You know the benefit of the fermentation on the oak. I think all of you guys as a winemaker, you know what are the differences from that. We wanted to have this in the bottle for the secondary fermentation. So we have trapped a little piece of our oak alternative with different toasting. You have fresh and you have sensation inside. We have put them in, we put that in a bidule, and you can do your secondary fermentation plus aging on oak with all the reaction and the aromatic interaction that this brings. So I hope you will start with a few experiment guys at your winery with that, and hopefully within few months I'll be able to travel and taste this with you. So yeah, a big thank you really for your attention. Sorry for being so long, and I will try to go to the questions. There are some. I see Kathleen. There is a question, but it disappeared from my screen. So how does Parolis Life compare to Anolis during Tirage? Yes, Anolis Life is going to be more. Anolis Life is going to be more the one to look at. It's a new product, and that would be more replacing the fresh aroma. Okay, so we're talking about preservation of certain freshness, preservation of certain fruitiness, most likely Charmat-like, very, I think this is going to be more towards this side. I would look at it. Sorry, I need to find. Okay.
Thank you, Francois. There's one other question from Brett. He had to leave, but he has a question regarding achieving tartrate stability in a pétillant naturel. How would you go about that, given that he's not working with a base wine?
So he's not working with the base wine, but he's doing pétillant?
Yes, that's what it looks like his question is about.
That's a bit tricky. I might have to talk with him because pétillant, if you don't bottle from the juice, I don't see how you're going to do a pétillant. Not sure.
Okay, and then looks like, and we can send that question off back to him. We can answer him directly afterwards. And then it looks like there's another question regarding if there's any organoleptic change, example, bitterness or anything in the base wine, if tannins were added during the tirage. So I'm guessing that's the TannSpark reference.
No. In terms of no, you won't. We're not adding a lot to start with. It's very limited in terms of dosage. So, and definitely not. If you go to any sensation of bitterness, that wouldn't be the right product. Definitely not. The blend we choose is very soft. It's a liquid tannin as well. You see, that's very rare to be noticeable, and it softens it a bit. And definitely the sensation is something more structured, meaning you have like more density in the feeling in mouth, but no harshness, no grain, no dryness whatsoever, bitterness coming. And you have also a sensation that just the wine goes younger 2-3 months. Like you go back in the future. Yes.
Well, thank you very much. I know it's late there, Francois. I know it's in the evening for you. Thank you for everyone for attending. That was a great overview of prepping your wine up to tirage, going over all the adjuncts, the TannSpark, difference of yeast and roles that they all play. Everything comes together for the goal, which is high quality sparkling production here. And great job touching on that new product, the Nova Spark. Very excited about that with the little oak block.
Yeah, this is fabulous. I mean, honestly, I'm super surprised.
Yeah,
this is good. Really fun.
Well, thank you again. If anyone has any additional questions, feel free to reach out to your representative in your area. Again, thank you, everyone, and we will see you next time. Bye.
Bye.